Okay, dim the lights and gather round because today we're diving into something in programming that honestly feels a bit like dark magic. We're talking about the voodoo effect. Have you ever written code where you modify one seemingly innocent variable and suddenly, completely elsewhere in your program, another variable inexplicably changes state? It's terrifying, right? It literally feels like your code is haunted. But don't worry, today we're going to shine a flashlight into the darkest corners of Java memory to demystify this whole paranormal activity. We'll be using some brilliant insights from Dr. Yayati Gupta's notes on object interconnection, so brace yourselves for a chilling explainer on reference variables, the stack, and the heap. Let's quickly crack open our grimoire for today. We'll review the core blocks of OOP, look at the actual Voodoo simulation code, uncover a huge mystery, demystify memory, and finally face the terrifying reality of aliasing.
All right, part one, the core blocks. Before we summon anything, we've got to understand our basic tools.
So think of a data member or an instance variable as the physical state of our subject. In our slightly macabre scenario today, we're tracking whether or not our subject's eye is intact. It's the raw data we care about. And right alongside that state, we have our behavior, the member functions, our methods. If the data member is the eye itself, the method is the action. It's the dark magic we perform to actually change that state, like the wicked act of poking it. State and behavior, right? The absolute basics. Moving to section 2, the Voodoo simulation code. This is where we start building our sinister little scenario. Check out this code snippet. We're setting up a person class, our template. Inside, there's just one highly vulnerable data member, a private boolean called isIPoked, and it's set to false. So right out of the gate, our person is completely safe, unpoked, and perfectly healthy. Then, we add our behavior, a method literally called pokeEye. And look what happens inside those curly braces. When you call this, it grabs that safe as eye poked variable and permanently flips it to true. Boom. The deed is done. The state is irreversibly changed. Okay, let's run our simulation down in the main method. First, we use the new keyword. We instantiate our victim. They are now alive in our program. But right below that is where the dark magic happens. We write person doll equals victim. We create a second variable, the doll, and literally assign it to our victim. With the trap set, we strike. We call doll.pokeEye. Notice we are absolutely only interacting with the doll variable here. We're just pressing our metaphorical needle into its code. Which brings us to section 3, the big mystery. Because now we have to check on our victim. We ask Java, hey, what's the status of the victim's eye? We print it out, and the console spits back, true. Let that sink in for a second. The victim's eye was actually poked. This is the crux of our whole explainer today. Why did the victim get poked when we only touched the doll? We never explicitly laid a finger on that victim variable after we made it. So how on earth did our code pull off this voodoo effect completely autonomously? Section 4, demystifying memory. To figure this out, we actually need to look under the hood at Java's execution memory map. Based on Dr. Gupta's notes, Java splits its memory into two totally distinct realms, the stack and the heap. The stack is super organized, really fast, and it holds your local variables. The heap, though, that's a massive open space for your dynamic object payloads. And you absolutely cannot understand the voodoo effect without getting this separation. Let's look at the heap first. When you type new person, that new keyword is the summoning spell. It triggers dynamic memory allocation. The computer physically carves out a chunk of the heap to hold the actual object payload, the literal isIPoked equals false data, and it lives at a very specific hexadecimal address. Just to make it easy, let's say that address is 0x004a. Meanwhile, over on the stack, what's going on? When we declared person victim, we made a reference variable. Here's the absolute kicker, guys. That variable does not store the person. It just stores the address, 0x004a. Think of the reference variable exactly like a TV remote control. It doesn't contain the TV, it just points across the void directly at the physical object sitting on the heap. Finally, section 5, the reality of aliasing. What happens when these remote controls start interacting with each other? Let's break down the actual spell here. Step 1, the victim variable gets its remote control, programmed with address 0x004a. Step 2, we declare doll equals victim. This is aliasing via assignment.
Step 3, by using that equals sign, we aren't creating a new person. We are literally just copying the value from the victim variable into the doll variable. And since that value is just the address, 0x004A gets copied into the doll. We duplicated the remote, not the actual body.
So here's the horrifying reality. Both our victim and our doll variables are sitting there independently on the stack, but they hold the exact same address, 0x004A. Two remote controls, but still only one physical person payload living on the heap. They are completely tethered to the exact same entity.
To quote the source material directly, when the doll calls poke-eye, it uses its remote to modify the shared person instance at 0x004A. The voodoo effect isn't magic at all. Modifying the doll is just pressing a button on the second remote, which alters that single shared instance on the heap. So when the victim variable checks its state later, it's just staring at that exact same, now altered body.
Which leaves us with a pretty chilling thought to wrap up this explainer. Think about the vast memory map of your applications, where objects are constantly being passed around and assigned to new variables left and right. If every object is just a memory address, who else is holding a remote control to your data? Seriously, be careful who you share your references with. Thanks for joining me today, and happy coding, if you dare.